All right, so here we've got a lot going on. It's not just our basic cos graph. We've got y equals 2 cos x plus pi minus 1. We're told that x lies between 0 and 2 pi. So the first thing you do when you look at this is say, right, we've got to decide whether we're working in degrees or radians. Now, because x is between 0 and 2 pi, it's a given that x is going to be in radians. So we're working between 0 and 2 pi. So we can't use degrees. Next thing is we've got the old A, B, C, D going on. So y equals A cos B inside of x plus C plus D. And that's the general form that we've talked about for the cos graph for transformations. So we've got A is the amplitude. We'll just use that, and that's equal to 2. So that's the A value. B, now outside here is a 1. So B gives the period. Well, B is not the period, but the period can be worked out by 2 pi over B, which in this case is 2 pi over 1, which is 2 pi. So that's all nice. C is the phase shift. In this case, it is pi. Now, because it is positive, it is pi to the left. We're going to move the whole graph pi to the left. And D, -1, so down 1. Okay, so we've got to start with our, well, won't start with y equals cos x. We'll start with y equals 2 cos x, and then we'll transform it. So let's just move down here and give ourselves a bit more space. Draw yourself a set of axes. We've got to draw it between 0 and 2 pi, so we can put this way over to the left here. And we see that we're going to start, our first transformation is y equals 2 cos x. So we're going to do that first, because this is what we're going to start working with. Then we'll do a phase shift of pi, and then we'll move it down 1. Okay, so as per normal, we do one complete period out, and we know that the period is 2 pi, so we're going to go across here to 2 pi. Let's see if I can do this a little bit better. So that'll be halfway. 1, 2, 3, 4. So there's 2 pi. There's pi. And this will be pi and 2. And this will be 3 pi and 2. And we're going to go between +2 and -2. So there's 2. And so that's 1, 2. -1, -2. We're actually going to have to come down a bit, so we'll go down there to -3. So here's my x, here's my y. And now if you're just doing it in black and white, which I'll do this one in black and white rather than use colour, so just show you, you could actually dot the line. So it's a cos graph. Cos normally starts at 1, but because this one has an amplitude of 2, we're going to actually start there. It's going to go through there, down to -2, come back up again and go up to there. Now, what I suggest you do is just dot all your lead up graphs, all your working graphs until you, and then draw the final graph in solid. So that's y equals 2 cos of x. One complete cycle. Then we're going to move every point pi to the left. Now this one works pretty good. So my 2 pi point is going to move back to there. So that point there, I will do in circles now. So that point has moved pi to the left. This point will go back to there. So I'm actually coming back down, so it's going to go through there. This point here will go to there. And because it has still got the same period, it's going to actually come back down there and go over to there. So, okay, we're going to go that's y equals cos of x plus pi. Sorry, it's 2 cos x plus pi. So it's going to look like that. Now our final step is to move this graph down 1 unit. So my equilibrium line at the moment is the x-axis. So if I'm going to move the equilibrium line down, we've got a lot of dotted lines going on here, but there's my equilibrium line. So it's going to oscillate 2 units up. So there's my top one. It's going to go up to that one, which is 1, and come down here to -3. So this graph here has got to move down 1 unit every unit. So I'll put it across that way. This one comes down to there. This one comes down to there. So if I draw that one, this is my final graph. And then this one will come down to there. This point will come down to there. And I've got, and that is the graph of y equals 2 cos x plus pi minus 1. Okay, so it goes between -3 and 1, so you can check that's still a distance, a vertical distance of 4. Half of 4 is 2, which is the amplitude, which is good. You could actually do values if you put your calculator into radian mode and said, all right, we've got here when pi, we've got a value of +1. So if you put 2 cos, now x is pi, so we're looking at when x is pi, we should get a y value of 1. So 2 cos of 2 pi minus 1. Put that in your calculator and you should get a value of 1, which corresponds to that point up there. So just to check, you could check some intermittent points to make sure that you've got it correct. Can I just, that sort of same sort of deal with a sine graph, but if you're given something like you're asked to sketch y equals -3 sine of 3x plus, let's go back to degrees, 180 minus 2. Okay. Let's have a look at what this does. I'm not going to graph it, but I'll just show you what goes on here. If you've got something like that, bear in mind that our standard form is y equals a sine b open bracket x plus c plus d. Now that's the general form for all transformations. At the moment we don't have it like that. We've got a bracket here and we've got 3x plus 180. Notice that the b value, you must have an x inside the brackets. We've got 3x inside the bracket there. So we have to factorize this bracket. So we get -3 sine 3 open bracket, then we'll get an x inside the bracket. Now 3 times what is 180? 60 minus 2. Now we've got it in the form that we need it. At the moment we don't. When we're given this example here, we don't have a b value yet. We have to make x inside the brackets. It can have no coefficient in front of it. So you have to factorize that bracket. This will have an amplitude. A is the amplitude, and that's equal to 3. So it has an amplitude of 3. The negative tells us that the graph is flipped. When I say it's flipped, the sine graph starts like that. So it is going to go down like that. So this is what I mean by it flipped. It'll be reflected in the x-axis. So the negative means the graph is flipped. The amplitude is 3. The period equals, now we see that we're working in degrees, so it'll be 360 over, here's my b value now, over b, which is equal to 360 over 3, which is equal to 120. C is the phase shift. Phase shift. Which is equal to 60 degrees. Now, because it's plus 60, it'll be 6 degrees to the left. And lastly, D equals -2, and that means it is 2 units down. Okay, so just be careful if you get something in that form, that you have to get x by itself, so you have to take a 3 out the front there. Then you can write down all those and go through. I would start with a y equals 3 sine x, and then flip it, and then do a phase shift, and then do a vertical shift.